This is a recording of a webinar presented by Dr. Susan Murphy on June 14, 2018. It consists of a 1-hour presentation followed by a question and answer session.
Thanks, Aaron. Appreciate it. It's great to be here with all of you today. So you'll see, hopefully you can see on your screen, you see the little icons of the variety of micro-randomized trials in which our lab is involved. Today, we're going to spend we'll spend pretty much the entire time using HeartSteps to make ideas clear. If you can see my pointer, you'll see the pointer pointing to HeartSteps. This will be the study that we'll use to clarify the ideas. However, I'll give you a link to the schematics for all these other studies, and they're quite interesting, so highly recommend checking out that link. So what we're going to do is we're going to start off, I'll describe HeartSteps so that I can use it as an example, and then we'll go on to the micro-randomized trial. So with HeartSteps, this is a project that involves 3 studies, the first of which has been completed, and that's the trial design you're going to see today. Across all of these, this entire project, the goal is to help individuals increase and sustain their physical activity level. The focus population will be are individuals who are at very high risk for coronary heart disease. So one of the themes of HeartSteps is to, as you see in that second bullet point, it's to increase activity by supporting opportunistic physical activity that people can do throughout the day. So something you can do in the setting that you're currently at with the weather the way it is right now. Now, if you've been working in mobile health, you know that in general, there's 2 types of interventional components that are used to support behavior change. One is a pull. This is the most common type of intervention component. And this pulls depend on the participant to access the support on the phone. So normally a variety of support is on the phone 24/7, and at any time the participant can access that support. Pushes are very different. Pushes are where the mobile device or a wearable interrupts the person in their daily life and attempts to provide some support. I'm going to return back to pushes as we go through, but I just want to make sure we're all on the same page. So here's an example of a pull from up. You just go to the phone, you open the app, you can self-monitor, see how many steps you had. You might be able to get some coping strategies if you're concerned. Say, if you're struggling with alcoholism, you might have some coping strategies to manage craving and stress. Often there is a help button in many of these interventions. The participant, you go to the phone, you press the help button, you request support. The great thing about pull components or interventions is you can provide enormous variety of different types of interventional support on the phone. Social support, helping people know where the nearest, say, AA meeting is in time and space. You know, it's really nice. It's very low burden because the participant or user doesn't have to even look at it if they don't want to. The problem in all of this is it depends on that individual to know when they need the support and to remember to do it at that time. That's the primary issue. Push interventions are very different. Like I said before, they may occur at a particular time in a particular context and according to something that the individual is doing at that time. And you see here on the left-hand side, at least it's the left of my screen, you see a list of possible kinds of pushes. In HeartSteps, we're going to focus on suggestions about physical activity. But there's all kinds of pushes, even pushes that help you create social linkages and so on, motivational. The nice thing about push interventions is we are able to use different sensors, wearable sensors, and analytic modeling to determine when it might be good to provide support. And we don't need to depend on the individual or the participants' self-awareness that at that moment they could really use some help. That's great. But the side effect of that is that they're very burdensome. They can be highly iatrogenic. Indeed, we can produce a negative kind of habituation where the person doesn't even see our message anymore because we've been messaging them too much, or they may even delete the app. So when you start to think about what kind of components, push components in particular, you want to include in your intervention, you really want to deliver these components at the right times, in the right context, and no more than needed. Because if you do too many, you can have these side effects. And this is where these micro-randomized trials come in. So if you were in a setting where you could deliver push components continuously, no iatrogenic effects, then there's no reason to experiment with whether or not you should deliver them or the type. So in HeartSteps, the first of the 3 trials that are part of HeartSteps, there was a wearable. You see a picture of it, the wristband, a jawbone wristband. From that, we have step count. And we had a whole variety of pull components, but 2 of the push components, one of which was this contextually aware suggestion for walking in the setting you were currently in. And another was a planning type suggestion where you would plan the next day's activity. So I want to talk to you a little bit more about this contextually tailored suggestion. So here's an example on your slide. This one, they were tailored to your location, home, office, or other, weekday versus weekend, the time of day, and the weather. So this was, you see it's in the mid-morning, and it's just a little suggestion. You go and you walk into, you see, for example, a squirrel. There were actually 2 types of suggestions that could appear on the lock screen, notifications that would appear on the lock screen. One is like the one we're seeing here. It takes a little bit of an effort, say 2 to 3 minutes. The other, though, is even less effort. It might be a suggestion to stand up and roll your arms or something of that type. Just interrupt sedentary behavior. So some of the questions we were dealing with as we thought about, well, in what settings or how often should we provide these contextually tailored activity suggestions are as on this screen. So, for example, is it even worth it to deliver these notifications on the lock screen? Do they really even impact people's step count? Do the walking and the anti-sitting suggestions work equally well? Maybe as soon as you stand up, you end up walking a little bit. So we could just give you an anti-sitting suggestion. Do people start to get tired of these suggestions, or in some ways the effect, if they are effective at all, does that effectiveness deteriorate with time? Possibly due to burden, possibly due to habituation. And then you see other questions as well related to moderation in certain contexts, or the suggestions more or less effective. We want to answer these kinds of questions. And we have other components as well, which we have similar questions that we want to address. So what we're going to go to is a micro-randomized trial, and this is the trial we ran, and we're going to run 2 more of these trials in the HeartSteps project. So what are the elements of a micro-randomized trial? So let's think about the kind of data you might get on each participant, each individual. This is akin to a time series, and the O's represent observations at a particular time, a decision point we call it. The A's represent some coding of the possible different kinds of intervention options. I'm going to talk about this a little bit more on the next slides. And then the Y's indicate an outcome that might occur because of our our treatment, our intervention option. Notice how I indexed the outcome by t+1, whereas the intervention is indexed by t. That's just to remind myself that outcome occurs after we deliver interventions. So decision points, what should these be? And these are times at which you might be able to deliver conceptually, you might be able to deliver a treatment. And usually they come in two types, regular intervals in time or at user demand. We're going to focus on regular intervals in time. And in actuality, the closer the intervals in time that the decision points come, the more real time the intervention will appear to the participant. These do not mean that they get tons of treatment, because most of the time at a decision point, we won't treat. So now in HeartSteps, when we were designing HeartSteps, we actually thought we should go for every minute for the decision points, because at any given minute, you could provide a suggestion, contextually tailored suggestion. But then when we looked at a large amount of jawbone data, we noticed that at least for people who had regular jobs, the within-person variance in their step count tended to be highest around 5 times that was related to their job before they go to work, mid-morning, right around lunch, and so on. And these are about every 2 to 2.5 hours. Now, everybody has a different work schedule, so the actual time stamps of the 2 to 2 each one differ from person to person, but approximately every 2 to 2.5 hours for people who have a regular job. So we ended up, instead of using the minute by minute, we ended up going with these every 2 to 2.5 hours. That meant we had 5 decision points per day. And by going to this, we increased the chance that we might have an impact on the individual. If we stuck with the minute by minute, we'd have been providing some suggestions in minutes where they were just always sedentary at that minute. And we might not have had much of a chance to impact their behavior. Observations, this is the data that accrues from one decision point to the next. So again, there's 2 flavors, passively collected via like the jawbone wristband. You can imagine a whole variety of different types of sensors. A lot of the sensors actually are on the phone, and then actively collected via self-report. And as you know, probably well know, part of a lot of research is going into how can we reduce the amount of active data collection and increase passive data collection, because active data collection is quite intrusive and burdensome. At the bottom of the screen, I list some of the kinds of data we have in HeartSteps. Some of these are outputs of different algorithms, like classifications, whether or not you're going really fast, so you might be driving a vehicle, or you're walking, or you're sedentary. Your current location, are you at home, office, work? How busy your calendar is for the next couple hours, and so on. We also, in this first study, it was a 42-day study, we had self-report every evening. So we have some self-report data as well. The intervention options or treatments that we were looking at were these contextually tailored activity suggestions. At least that's what we're going to focus on for the time being right now. You see I've listed 2 types. Usually you can have different types of treatments, or you can look at whether to provide a treatment. In fact, in HeartSteps, we do both, but for right now, we're going to focus on, do we provide a tailored activity suggestion versus nothing at all? And the reason why we're looking at something versus nothing is there is this potential to increase habituation. By that, I mean people ignore the message eventually. So we want to really, many times we're going to decide just not to provide any intervention at all. I did list both treatments and engagement strategies. A lot of our more recent micro-randomized trials involve how to help people stay engaged, say either with data collection or with engaged enough so with the wearables so that we can intervene when they need to. So you can, when I show you the link to some of these trials, you can check that out. So on the bottom of the slide, you can see a little example. Again, it's the second example I've given you of a notification that can occur. This one occurred early in the morning. It was a pretty cold day, and it was a work day. So you can tell that from the content of that notification. What's interesting is that you have 3 ways to wipe this notification off. You can press thumbs down. You didn't like it. Thumbs up. You liked it. Or you can press the middle button, and you can turn off the intervention. You can turn it off for a particular number of hours. So you have control if you're the user. Now, it turns out with these studies, the kind of studies we're looking at, availability rears its head. It's not always the case with all intervention components, but certainly with these contextually tailored activity suggestions, availability is really important. And so I want to talk about that. So the sensors on the phone told us if you might be driving a vehicle. If you could be driving a vehicle, we didn't want the phone to light up, audibly ping, and possibly distract you from your driving. So in that case, you were considered unavailable for treatment at that decision point. Remember, there's 5 decision points per day, 42-day study. So that would be one way you wouldn't be available for a message, an activity suggestion. Another way was if we detected that you were currently walking, we didn't want to ping you and notify you and suggest a totally different walking activity. So again, if you're currently walking, we considered you unavailable. And the last way that you could be unavailable in HeartSteps would be as if you had turned off the intervention, like I indicated on the past slide. So when we go to look at deciding whether or not an intervention is useful or not, we're going to be looking at the times in which a person is available. Notice that availability is always known prior to the intervention delivery. And I'm going to use in the next slides, I'll use IT equal 1 if the individual is available, and IT equals 0 if the individual is not. Just as a reminder, availability is not like adherence. Adherence occurs after you get treatment. Availability is known prior to treatment. The outcome, in most of these cases with these intervention pushes, they're designed to have, the goal, of course, is to have some longer term impact on the person's health. For example, in HeartSteps, we wanted to increase activity over the duration of the 42-day study. But those little activity suggestions, they were intended to give you an idea of what you could do in that moment in your life. So that's why the focus of the activity suggestion is what we call a proximal outcome, because it's proximal in time. And we actually chose 30 minutes. And there was a lot of discussion about this, because you might think, well, maybe we should look at their outcome over the next hour. But we were concerned that if you waited a whole hour, they could have moved out of their current context. And the suggestion that we gave them was no longer relevant for the setting they'd be in. So we chose 30 minutes. So usually, in this case, the proximal outcome is a near-time measure of the longer-term outcome, that is, increasing activity over the 42-day study. Now, in general, that may not be the case. Here's it in this slide. I included this slide to indicate that. So in HeartSteps, it's like one of these, the first item, short-term targeted behavior. But often the proximal outcome is thought to be a mediator in a causal chain. So for example, if we're trying to help you quit smoking, we might have the intervention component that targets stress. And then the short-term proximal outcome might be reduction in stress or prevention of near-time stress. If it's an engagement intervention, it might be engagement with the mobile app. Okay, so what happens in a micro-randomized trial? Here, each person is randomized many, many times. Every time they hit a decision point, they get randomized. So in HeartSteps, it's a 42-day study. There's 5 times a day. That means that each person could be randomized 210 times. And you can think of these as full factorial studies over time. So you cross all the two options deliver a suggestion versus not at time 1, with a complete cross of 2 suggestions at time 2, deliver versus not, plus with a complete cross at time 3, deliver versus not, and so on and so forth. When you run a trial, you want to record the outcomes, your proximal outcome. If you have a health outcome you're interested in, like in a smoking study, you might look at the time till relapse. That would be a distal outcome. You want to record the context, all the important sensor data, self-report data. At each decision point, you randomize, you record how you randomized, and then after the study's over, you assess treatment effects. I think many people are tuned into this slide. It's something that we all understand. I just want to make sure that to be clear. So why are we randomizing? We know that randomization plus a representative sample of participants is a gold standard in providing data to assess causal effects. And we're really interested in what is the cause. Does this contextually tailored activity suggestion, does it really increase step count versus no suggestion at all? And by having sequential randomizations, we'll be able to assess different types of moderation analyses. For example, the past dose, the past number of times we've notified you over the past couple of days, does that interact with the effectiveness of the current notification, current suggestion? And does location or does weather interact with the effectiveness of the current suggestion? So in a micro-randomized trial, when we think about sizing the trial, we have to really think hard about what the inferential target is. And that's what we're going to talk about next. And to me, this is, at least from my perspective, I think this is one of the hardest parts for me to understand and to communicate. So how do we justify the experimental trial cost? You know, we're going to have a number of participants come through. We have to develop a mobile app. This is not a cheap thing to do. So what we're going to do is to size the study, that is, determine the number of participants. We're going to address a question that we can state very clearly across disciplinary boundaries, and we'll be able to provide guarantees. We'll be able to say that our power to detect a certain standardized effect is 0.8, for example. And then we'll ensure, though, that when we design that trial, that people who come after us who want to look at that data, they may want to do mediational analyses, moderation analyses, they'll be able to do their analyses. That'll be really important. So as we thought about how to size or what question should we first address, what should our primary analysis concern, would be, is there any effect at all of these tailored activity suggestions? I mean, is it even, you know, is there any effect at all? This is a main effect. So go back to HeartSteps, 42-day study, whether to provide a tailored activity recommendation at each of the 5 decision points per day. AT is coded 0, 1, 1 if you provide a message, 0 otherwise. We're going to test for the main effects. That is there an impact of the tailored activity suggestion on your 30-minute step count? And when we were designing HeartSteps, we were thinking, well, there's 5 times a day. We want to provide around an average of 2 suggestions per day. So we were thinking to randomize with probability 0.4, because that would give us an average of 2 suggestions per day. Now, we do have a time-varying treatment here, because at each decision time, you could either get a message versus not, and it goes over the whole study. So the minute you have a time-varying treatment, you might think, well, we have a time-varying effect too. And in fact, because of the potential for burden, we're particularly concerned about this time-varying effect, because you have a potential for accumulating habituation. I just don't even see the message anymore, and so the effectiveness dissipates. And or I'm burdened by it, so I'd ignore the message. So when we think about a test statistic or a main effect, just as we have a time-varying treatment, we'll have a time-varying main effect. And when we were designing HeartSteps, I was very concerned about this burden issue. So I really, we were all very worried about the effect dissipating with time. Again, the availability issue came up. We knew that when people weren't available, we wouldn't be able to provide an intervention. So when we think about a main effect, we're really talking at a particular decision point, we're talking about the effect among those people who are available. And I say that in words in this last bullet point. So what is the main effect? It's a contrast between available people at that time who are assigned a message versus available people at that time who are not assigned a message. What is the difference in their 30-minute step count following that decision point? Oh man, this is a technical slide. So what I'm doing is I'm using potential outcomes because I want to mathematize, I want to be real precise about what this main effect is, this time varying main effect. And capital A's mean randomized treatments, they're binary in our case, and lowercase a, that means a realization. So if you have a lowercase a1 through at, that's just a pattern of zeros and ones, depending on whether or not the person got the suggestion or not. And you can imagine on each individual at any given time, their 30-minute step count after a decision point could have been impacted by any of the treatments they got prior to that. And that's the reason why, I hope you can see my little arrow. I index their outcome by the pattern of treatments that they got in the past. And so my 30-minute step count following decision point T could have been impacted by any of the treatments I got up to that time. I can imagine me having an outcome for every pattern of zeros and ones. And of course, I'll only get to see one of those outcomes. Now, availability could also be impacted by past treatment. Remember, one of the reasons why you might not be available is because you're walking. So if you really like this intervention, you may start walking before each decision point. Now, notice that availability, it's indexed only by prior treatment, not by treatment at time t. And that's because treatment at time t hasn't happened yet. Availability is observed prior to treatment. So what's our main effect? Here it is here. So it's a causal effect. I'm going to point out how it's a causal effect. We have our treatment equal 1 at time t and my step count, minus my step count when the treatment's equal to 0 at time t. So it's a contrast in step count for an individual if they get treated, minus if they don't get treated. Now, they get to that point by some pattern of treatments, and that's the capital A t minus 1. Now, this is an average effect. It is conditional on availability. They have to be available before we're going to be interested in this contrast. And it's average because I didn't include gender in here. We're not conditioning on gender. It could be that men have a different treatment effect from women. I'm also not conditioning on the weather outside. So it truly is a main effect, an average effect. And I have a little schematic at the bottom of the slide. This is exactly what was in our head when we were designing this study. And it communicates our concerns about burden, actually. So across the horizontal axis is the 210 decision times. It's very coarse here because we're not taking into account time of day or anything like that. And across the y-axis is the standardized treatment effect. So this is a contrast between getting treatment versus not at each time. And you might imagine early in the study, this is where my little arrow is, there's really no effect. People are pretty confused. They get a notification, they don't know what to do. But then as time goes on, they see these notifications, they act on them if they get them, they don't act on them if they don't get them, and you get an increasing treatment effect. Totally nice. But then time continues on, they habituate, they start ignoring us, and the effect dissipates with time. This was our concern. So you get this sort of curvilinear relationship. So that's one kind of interpretation of this main effect. Another very different interpretation of this main effect is as follows. And of course, we're going to want to disentangle this in secondary analyses. At the beginning of the study, most everybody's available, and we're contrasting people, pretty much everyone who gets a treatment versus not at each time. But as time goes on, some of the people may have gotten really totally engaged, and they're no longer available anymore. So you can imagine a deteriorating effect, because the people who are still available are the most treatment resistant in some sense, because the people who really drank the Kool-Aid, they are already walking. So there's multiple reasons. One reason when we see a treatment effect may be due to habituation. We'll see a treatment effect that changes, decreases with time due to habituation. Another could be that the subpopulation at every time is evolving. And as time goes on, you get a more treatment-resistant subpopulation that you're providing the intervention to. It's very interesting, and it prompts a lot of interesting secondary analyses. The randomization that we're using, it's totally cool because it allows us to express this treatment effect in a very simple way. I've done that at the bottom of the slide. You see, it's just the mean 30-minute step count among those who are available and if treated, minus the mean 30-minute step count among those available and if not treated. And I'm just using a symbol of beta to incorporate that contrast. So we're going to go on to how we can think about the sample size for this type of a study. So what do we want to do? We want to figure out how many people we should recruit to go through this 42-day study so that we can detect whether or not there's a main effect. And we suspect this main effect is time varying. It's a causal effect because it's this contrast between getting treatment versus not, as I showed you on the prior slides. So our null hypothesis is, whoa, that is very poor slide. You notice that, Ashley? Very poor slide here. The null hypothesis is no effect at all. So the treatment effect is equal to 0 at all 210 time points. Game over. And because we were so worried about this, a decrease in effectiveness with time, we sized the study to target a particular low dimensional alternative. The alternative of the effect potentially, possibly increasing with time, but even if it did, it allowed for a decrease with time. And that's why at the bottom of the slide, you see the alternative that is targeted is a quadratic with time. It's actually a quadratic in day of the study. I'll show you that on the next slide, in the next couple of slides. Now, the choice of a particular alternative, that is this alternative, which is relatively smooth. It's at first the effect may increase if we have one at all, and then it might decrease. What that does is that's a low dimensional alternative hypothesis. And this has payoff. And the payoff is that when we go to size the study or and analyze the data, we're able to use contrasts not only of between subject outcomes, those who got a treatment at a particular time versus those who did not. We're also able to use within subject contrasts, that is, times at which you got a treatment versus times at which you didn't. And it's all because of this alternative targeting a relatively low dimensional quadratic, in this case, alternative. If we had said that the alternative could be of any kind, there's no relationship between the treatment effect at decision point 199 and decision point 200, then you would essentially be sizing the study as if it's a two-arm trial. But here, because we're assuming that the treatment effect is probably similar at time 199 and time 200, might be slightly lower, slightly higher, we are able to use within subject contrast. That means we get smaller sample sizes. We're able to use smaller sample sizes. It's really nice. So the way we're going to form our test statistic is we're going to do something that looks much like a least squares analysis. And it's essentially, the whole purpose is not a model fitting exercise, it's really construction of a test statistic. And this will involve the use of the randomization probability. Remember, in HeartSteps, we're randomizing it each time with probability 0.4 to treatment. At least that's how we plan the study. We will be focusing on quadratic alternatives. And so when we form our least squares, we'll allow a quadratic alternative. We'll use a quadratic. And this is just an approximation. It's not intended to be a modeling exercise. It's to get a test statistic. And so here you see at the bottom, you see how we target in our test statistic a quadratic in treatment effect in day of study. How do we, now, as you well know, that when you go to size a study, you have to you have to use standardized effect sizes. So how do we do that here? So what we do is we have 3 parameters we need to ascertain, and they're the intercept in our alternative, that is the quadratic, the slope, and the quadratic term. So each one we're going to think of as a standardized effect. So D here D indicates the standardized effect, and of course D is the beta coefficient divided by the variance, the standard deviation. How do we do this? We have a sample size calculator. I'll provide a link shortly to this. What we do in this particular case is we think, well, what would the initial effect be of the intervention on the very first day of the study? And then if we thought of the effect averaged over the duration of the 42 days, what do we think the standardized effect would be? And then we also think, well, at what day do we think we might get a maximal effect? So we did that, and then from these 3, if we answer these 3 questions, we can solve for our 3 standardized terms and then size the study. So we did this with HeartSteps, and we wanted to be really conservative here. So we said, okay, first day of the study, no effect at all. That's that first little blue box. I'll give you a variety of average standardized effect sizes over the whole 42 days on the next slide. And then we thought, well, okay, so 42-day study, when should we expect to start seeing things go down the tubes, get really bad? We thought, well, maybe around day 28, around halfway through the study, the effect is going to dissipate. So here's the sample, the output of the sample size calculator. As I said, I'll give you a link to it shortly. You see the standardized effect sizes here. They're pretty low. If you're used to Cohen's effect sizes, they're very low. And the reason why they're so very low is when we were sizing this study, we just had no idea of how small they might be. So we really aimed for much smaller than a small standardized effect size. Now, you do have to specify how often you think people will be available. And so you see the 2 sample sizes, number of participants are for 70% or 50% availability. Of course, the less people are available, the more people you need. And so you can see those numbers here. In HeartSteps, the actual study, we recruited 40 people. So we were thinking of the larger, the lowest stand. And it turns out in the actual study, we had around 80% availability. So we're being very conservative here. I wanted to show you some, this slide is to actually prompt me to tell you about this sample size calculator. It actually works pretty well because we were aiming for 80% power to detect an effect, average effect. It has one deficit, and that is that if the variance of your treatment, if your outcome under treatment is really different from the variance of your outcome under no treatment, you might not get a 0.8 power, you might get around 0.75 or 0.73 power. This is really important thing for us to communicate, because this means when we go to binary proximal outcomes, we need a new sample size calculator. because there for sure will have different variances. Here's a schematic of the HeartSteps study that was run. I did mention at the very beginning of this talk that there were other components being randomized, so I want to go through that with you. But let's just go through this little schematic. It's a little simplified, but it still gets the main ideas. You have all these observations that are in this rectangular, skewed rectangular box. You move through 5 times a day. I hope everybody can see that. Just squint really hard. And you assess if the person is driving at that time. If you know they're not driving, then you assess, are they walking? If you know that they're not walking, then you randomize them, and you randomize them so that now, actually, once we ended up running the study, we actually increased the randomization probability to 0.6. So that's why it says 3 times a day. When we were planning the study, we thought the randomization probably would be lower. Here you see, you start the intervention, you get the proximal outcome over the next 30 minutes, like we discussed. Now, there was another intervention component that was quite cool, and that was every evening. You could be randomized to plan your next day's activity. Notice the different time scales. One randomization is occurring 5 times a day. The other is occurring every evening. And if you come to my next one-on-one, I'm going to go through the data analyses for this study. And amazingly, we got some really interesting results that I will leave you to discover. That way you'll come back. So I just want to have some warnings here. If you go to plan a micro-randomized trial, you really want to be conservative as always when you size a study, when you determine the number of participants. Underestimate the amount of time people are going to be available, like we did. We thought 70% or 50%. In actuality, it was 80%. And as always, you underestimate the average standardized effect size. If you overestimate either one of these, then you're not going to recruit enough participants, and your power won't be what you want it to be. I want to go through and contrast micro-randomized trials with some other designs. Ashley, who's sitting next to me, may interrupt me and tell me I have to stop. So first, here is the randomized controlled trial. I love randomized controlled trials. They are optimal. Randomized controlled trials are optimal for evaluating a completely formed intervention package versus an appropriate, suitable control. They're not optimal for constructing an intervention. And so here I use this word JEDI, this abbreviation. This is a mobile health intervention, just-in-time adaptive intervention. If you want to construct a mobile health intervention, as we do in HeartSteps, you don't want to use a randomized controlled trial. That's not suitable for that. It's suitable for evaluating your already constructed mobile health intervention. So what micro-randomized trial will do, it allows us to even know if these contextually tailored suggestions are even worthwhile providing, and in what context they're worthwhile to provide. Okay, so I wanted to talk to you about contrast micro-randomized trials with N-of-1 trials, which are incredibly interesting. And N-of-1 trials have originated, it appears to me as if they originated independently in 2 different communities. And it's quite interesting. These are usual trials where you have one or a few number of participants, and you conduct crossover trials within that person, multiple crossover trials in which the order of the treatments are randomized within a person. In the clinical setting, these were often used because you were looking at a rare illness, and you could not conduct a randomized controlled trial. And the inferential target was, is one-time treatment A better or worse than one-time treatment B? And you wanted to be in a setting where your treatments had minimal delayed effects, minimal carryover effects, or you had to include a washout period. Now, that's very different from the micro-randomized trial. Unfortunately, we have We would like to have very positive carryover effects in the sense that you really get engaged and you start walking, and so you're not available anymore. Or we'd like to avoid negative carryover effects, that is, you habituate and disengage. We know we're going to have delayed effects. Now, there's another way in which N-of-1 trials arose. And a lot of my colleagues are very interested in it from this point of view, and that's in the behavioral science field. And here the goal is to ascertain individual level causal effects. You have Jane in front of you. You want to know, is one-time treatment A better for Jane than one-time treatment B? So for Jane, who is in front of you, is treatment A better than treatment B? So in these settings, these are trials that are often run by domain experts, behavioral scientists. And this is because they often bring very nuanced assumptions based on theory, behavioral science theory, in order to triangulate on individual level effects. And a really beautiful review of this is in McDonald. It came out last year in 2017. Highly recommend this paper. I think I gave you a reference for the clinical setting as well. Yeah, that site at the bottom is quite nice for the more clinical viewpoint. Now, in our setting with micro-randomized trials, we believe that treatment A might be better in one context than another. And as your context dynamically changes, you may do better with treatment B than treatment A. But we're not necessarily going after individual level effects. We try to get close to the individual by having a good measure of context, a relevant measure of context, and we believe we want to know whether or not our treatment impacts you differentially depending on the context or how the context evolves over time. But we don't go directly after individual level effects. This micro-randomized trials are much more from a standard clinical trials perspective in which you use multiple individuals. There's another type of experiment, factorial experiment. Many of you are likely familiar with factorial experiments. These are designs in which you have one or more components and you can cross the components. So here's a little schematic, treatment A and treatment B. A person can receive any combination of no and yes with treatment A and treatment B. And in fact, an MRT is sort of like that. Treatment A might be whether we provide a suggestion at time 1. Treatment B is whether or not we provide a suggestion at time 2, decision point 2, and so on and so forth. So it's a special form of a factorial where the factors occur over time. But we also have factors that are occurring at different time scales. Like we had the evening planning that we randomized in HeartSteps. So it is a factorial design. It's a very special type of factorial design, the MRT. And here I'm just reiterating the fact that in MRTs, you can have factors that operate in very different time scales. And here's the 2 examples in the case of HeartSteps. One thing that's happened is I've had a lot of collaborators really, they wanted to use micro-randomized trials. They thought, well, it might be really interesting in their particular scientific problem. But there are settings in which you really should not be using these trials. For example, you might be very interested in suicide prevention, and you want to figure out what kind of alert should you provide if an individual is currently at very high risk for suicide. This is not a setting in which you want to use a micro-randomized trial. People they're at high risk for suicide very rarely. Even people who generally, on average, are at high risk, they're not at high risk 3 or 4 times every day or every single day. So you want to really use these when malleable circumstances or change rapidly. So helping people manage stress, helping people manage urge to smoke, helping people manage craving, adherence to medication. That's a prime because you have to use medications usually every day or multiple times per day, and so on. Another setting in which at this time micro-randomized trials are not useful is if you can't feasibly assess the proximal outcome. And this is usually a limitation of our wearables, our sensors. So you want to be in a setting where you can unobtrusively sense that proximal outcome. So for example, in one study we're involved in with smoking, we have wearables that allow us to sense whether or not you're stressed in real time. So we can use it as a proximal outcome, but in general, you might not be able to do that. Here's the links to these to the sites where you can find the calculators. And I really encourage you to check out the other MRTs. They're totally cool. I'm actually going to ask Erin if I can do another one-on-one, an additional one on all these case studies for the MRTs. It's just mainly because it's just so exciting for me. To summarize, MRTs are they're factorial designs. They have time-varying intervention components, that is factors. Thus, they end up with time-varying main effects. I have a whole bunch of collaborators. I'm a really fortunate person. These collaborators span across the field, human-computer interaction. There's Peja Klashnia, he's the PI of HeartSteps. I have a little arrow on him. Linda Collins, she's PI of the Methodology Center. Eric Heckler, he's involved on HeartSteps with us. Billy Nahum Shani, she's a behavioral scientist. She's involved in many of our studies. Santosh Kumar, he's a computer scientist. We just have a lot of computer scientists involved. We have great programmers. I could just go on and on. I'm really a fortunate person, I have to say. Okay, thank you. I'm not sure what I'm supposed to do right now, Ashley.
Yeah, so if you guys have any questions, you can use the chat to send them to me, and then I will ask Susan your questions. So we'll give you guys a few minutes to type them up.
Okay, we're going to start now. Ashley, you're going to read the questions to me, right? And then I answer them. Is that how it goes?
Yeah. So I've gotten a few questions, and feel free to keep typing them in if you have them, and we'll just take it from there. So our first question is, you mentioned that MRTs are not useful when the proximal outcome has to be assessed obtrusively. For outcomes like change in emotional state, how have you measured them, and is this feasible to do on a large scale or with a small budget?
Yeah, so in the Sense to Stop study, that's that smoking cessation study, you can find the schematic at this link at the bottom of the slide. This was a prototype study in which participants were wearing a variety of wearables, and we had like 35 sensor streams, and we were measuring not perceived stress, but physiological stress. So in that case, we had classifications. We had an algorithm that used those 35 sensor streams to provide every minute a classification of whether or not the person was physiologically stressed. Now, these could only be at minutes that they were not physically active, because you can't assess physiological stress when people are active. But with that, we can obtain the proximal outcome of time until next stressed, or a fraction of time stressed over the next. And since to stop, the proximal outcome is fraction of time stressed over the subsequent 2 hours following a decision point. So we'll have that type of information. In general, like suppose I was developing an intervention that was about craving, for example. That would be really interesting, particularly in the addiction field. There, it would be pretty hard to sense craving. So I think there's a number of proximal outcomes like craving that we don't yet have good sensor data that gives us a good classification of whether or not they're currently experiencing, for example, craving. But that's all coming, and it's coming a lot faster than one might think. I know already a number of teams have started, are developing classifications of physiological stress based on just wristbands, whereas we were using a lot more sensors, wearables than wristbands. Also, you probably know that now they're starting to sew wearables into clothing. So that would be another very unobtrusive way to obtain physiological type measurements. You can have other kinds of interventions that are interactive, but they are burdensome for the participant to report. Say, like to report my craving level 2 hours, within 2 hours after you suggested a way for me to help manage my craving. That would be pretty burdensome. Okay, Ashley.
Okay, great. So our second question, well, first, thanking you for your excellent introduction to MRTs. Can you please talk about how you'd introduce testing of other variables such as the location triggers or gender differences you mentioned? So to understand how optimal intervention would vary between groups.
Right. So, right. These are moderation analyses, and in fact, we have developed an approach to assess moderation in these settings. You can find, I have a ton of talks at my website. Is there any way for us to give them a link to my website? I don't really know. You might ask Erin if we can do that somehow.
Do you want to include it in the slides that we might give
Okay, I
them?
could edit the slides and put it, because I have a lot of slides on my website, as well as slides of workshops that I've given and some YouTube videos, and you'll see me talking about the one method to assess moderation. Now, there's other methods as well that we're working on that have to do with what's called reinforcement learning, and we hope to have work out on the website soon about that.
Okay, so that leads in really well to the next question, which is, could one adaptively change the probability of different treatment options for individual participants based on response up to a point in time, like increasing the probability of options that seem to be improving a proximal outcome?
Yeah, so the next HeartSteps is going in this summer. It's so exciting, at least for me. So in the next HeartSteps, it'll go in this summer, and one of the intervention components are these contextually tailored activity suggestions. And we will have an algorithm running that will slowly change those randomization probabilities, always moving them in the direction of the best perform, whether it's useful or not to provide a suggestion at that time in that context. Now, so the randomization probability will always be non-zero, but it will be higher if you're more likely to respond to an activity suggestion. And it'll be lower if in that context at that time, you're less likely to respond to an activity suggestion. So we are doing exactly that. We are going to do it in a way, though, so that after the study is over, people will still be able to use that data to conduct a wide variety of subsequent data analyses.
Okay, so that's our last question, but we have some prepared questions that we often get about MRTs, so I'll go ahead and start asking those. So Susan, what is the role of the distal outcome in an MRT?
Yeah, so a lot of people, I didn't even mention that here, but most MRTs, the design of these trials, it's heavily informed by behavioral science. So usually in our mind, we think of there being multiple pathways whereby a person can either improve their health, that is, take on new positive behaviors, or reduce negative behaviors. And then we think of intervention components that target those different pathways. So the distal outcome is always the long-term health outcome we want. And then we think of all the causal pathways to that long-term health outcome that we might want to target. The proximal outcome are those mediators for each one of those targeted pathways. So the distal outcome plays an absolutely critical role in the behavioral science that is used to structure the design of the micro-randomized trial. But it doesn't play an analytic role.
Thank you. The next question, why do we need micro-randomized trials?
So I think with that one, the main reason, of course, is because you're interested in understanding. For example, it could be, let's just think on a particular day, if I provide an activity suggestion versus if I don't provide that activity suggestion, that the effectiveness of that suggestion may depend on how many times I gave you suggestions over the past 24 hours. In that setting, you want to have this sequential time-varying treatment so that you can look at moderation by prior dose. So that's one way. Another way too is I also want to have sequences of treatments because I may want to look at features of your past behavior while you were under treatment and see how that moderates the effect of present treatment. For example, how variable my activity level has been under prior treatment. Does that moderate the effect of subsequent treatment?
Okay, and the next question we have, with sequential randomization, patients will experience sequences of different treatments. How do we control or adjust for the crossover effects?
And we get this question a whole lot actually, and I hinted at it when we talked about micro-randomized trials as compared and contrasted with N of 1 studies. And you really don't want to have carryover effects if you're trying to ascertain, does one-time treatment A work better than one-time treatment B? You really don't want to have crossover effects. But here, this is all about sequencing of treatments. We know that this is a dynamic setting in the context of a person's life. And so we want to figure out how to sequence it. We want to actually design these interventions so we maximize positive carryover effects if we can. That is, we build you up so you're more responsive to subsequent treatment, and we reduce the effects of habituation and burden.
Okay, and so what are some guidelines for choosing the decision points?
This is one that I've been struggling with a lot lately because a lot of people have been asking about this question. And I personally always want to choose the decision points as fine intervals in time. And the reason why I want to do that is because I want the participant to experience the intervention as if it can provide support at any time. However, like I explained in HeartSteps, it's not always a great idea because it could be that most of the time in that person's life, this intervention just doesn't make any sense. And so like with HeartSteps, there was really only a lot of opportunity to change these people's behaviors at these 5 times. And this was mainly due to their job situation. And so it made a lot of sense to choose the 5 time points. In Sense to Stop, that's a smoking cessation study. We actually did choose every single minute because we had classifications of physiological stress each minute. In another study that you can find at that bottom link, Sarah, this was a study to increase engagement in data collection, and we were trying to encourage people to answer questions in the evening. So the timing of the decision points was related to the timing of when we wanted them to answer the questions in the evening. And these were kids, so the timing was also was constrained because they needed to be out of school. Yeah.
Okay, and we have one more question. If anyone has something still want to ask, still feel free to type it into the chat function. But our last question is how to decide the duration over which one should define the proximal outcome.
Oh yeah, So this is another thorny issue, at least it has been in our teams. Of course, sometimes it's really obvious. If your goal is to increase medication adherence and it's a medication you need to take in the evening, then it's absolutely clear that whatever message you provide or reminder in the day, the time duration for the proximal outcome is whether or not they took the intervention in the evening. I mean, it's just obvious. But for example, in Sense to Stop, we really went round and round. Like we ended up having the proximal outcome be the fraction of time stressed over the subsequent 2 hours following a decision point. The reason I wanted it to be 1 hour because I wanted to ensure that there was a high signal relative to the noise. The longer the time we wait, the more kinds of things happen in people's lives, and you get noisy and noisier data. On the other hand, the argument for 2 hours was that we were hoping this particular intervention was practicing a mindfulness exercise, and we were hoping that practicing that exercise would reduce the time, would prevent further stress. And it was felt like you needed at least 2 hours to even incur or potentially experience further stress. So you can see why a person would go for 2 hours instead of 1 hour. So the real issue is signal to noise ratio. The shorter the time period, you want to have just enough time to get a good signal, but not too long so that too many things happen in that person's life and you get really noisy data. I think right now at this stage with micro-randomized trials, a lot of this means bringing the team together and really hashing that out, these considerations of signal to noise ratio in terms of the time duration.
Okay, so we actually have 2 more questions. The question we got from the chat is, what statistical approaches do you favor for understanding the data from micro-randomized trials?
Yeah, so I used to, originally when I first got into this area, I thought I would use multi-level models because I really like how multi-level models utilize a model for the within-person correlation across time to increase the power of the any hypothesis test. However, it turns out that in these types of settings, because we're often adjusting for time varying context, which could have been impacted by prior treatment, that you shouldn't model the correlation across time. You need to adjust for it in the standard errors, but you shouldn't model it. So most of our methods we actually developed, they look very similar to generalized estimating equations, even though they're not, but they feel very similar. And because of that similarity, it helps people do a lot of model checking, which I think is a really good thing. So in general, right now, at least, we're not using multi-level models, one of my favorite models, because we don't want to contaminate the causal, we don't want to bias the causal effects. Longer term, we'd like to figure out how can you use multi-level models and not bias the causal effect in these settings.
Okay, and our last question is, if my team wanted to collaborate on an MRT, I suspect you are bombarded with requests like this constantly and do not have the availability to do so. With that in mind, are there collaborators you recommend who might have the availability to collaborate on such a trial?
Yeah, so right now, there's a group of us at Michigan and our group. And right now what people do is they email me describing what they want to do, and I then try and put them in touch with someone I feel confident will, come through for them. I'll do that. Or sometimes actually people will want to talk to me about a micro-randomized trial, and it just turns out that's not the best trial for the science. And, the science is always more important. But when it appears that the micro-randomized trial might be best, and if our lab has bandwidth, then what we'll do is I'll have a phone call with the person. We'll try and get into it a little bit more to see whether or not there's really potential for micro-randomized trial. And if it goes past the phone call, then the next step is the collaborative team will come and visit us, and we'll help them frame the specific aims and the statistics so that they match the science. We do that in our lab because it's a training exercise for the postdocs and the grad students. It's really useful for them. So it's a great thing for us. And my collaborators, any collaborator that I would point you to would likely do the same thing. So it's a great opportunity. And often when people do come and visit us, they bring with them either a quantitative psychologist or biostatistician, and so that we can have a longer term relationship and help them when they go to do the data, advise the biostatistician or the quantitative psychologist how they can analyze the data. So if they have problems and so on.
Okay, yeah, thank you, Susan. And I want to thank our participants for their time and attention. And you can watch the Methodology Center's website, where there will be a video of the webinar posted and a copy of Susan's slides from today.
Yeah, and I'll put the my website, I'll put a link to it also on the slides. Thanks so much for joining us today.